All right, so we're just going to go real quick through some applications, just one problem, and hopefully you can kind of take what you know here and apply it to other problems. So let's go ahead and get started. And your objectives, you're going to be able to apply your knowledge of sinusoidal curves to problems related to the real world, and you're going to be able to answer specific questions with regards to these problems. So let's take a look at the one problem. So we have naturalists find that the population of some kinds of predatory animals, blah, blah, blah. Basically, they're saying that foxes in a certain forest, they vary sinusoidally with time. In other words, they go, their population does that. All right. So records started being kept when time, which we're going to call t, was equal to 0. Okay. After the time started being recorded, a minimum number, so this is important, minimum number, which was 200 foxes, occurred when t was 2.9 years. A maximum of 800 foxes occurred at t equals 5.1 years. All right, so the first thing we have to do is sketch a graph of this sinusoid. Now, I already did, but I want to kind of explain how I got this. So what I'm going to do is I'm going to kind of show you, this is the end product. What we know is that our minimum occurred at 2.9 years, and our population was 200. Our maximum occurred at 5.1 years, and was 800. So in order to find this graph, we need to determine if we're going to use sine and or cosine. So I say this is my general rule of thumb, and it seems to work pretty well. Use a cosine graph when given a maximum or a minimum. Okay, so use cosine then. Use sine if you are given a starting point and it's something that would go to one side of the starting point and to the other. It could be represented that way. For example, a roller coaster or a Ferris wheel. This is a really good example of a Ferris wheel. Okay, with a Ferris wheel, you start at the bottom, okay, and you ride it up, and then it comes back down, and then it goes back up, and it comes back down. But you start at the bottom. Sine would be like the pendulum of a clock. So if we're given a pendulum, and we're saying its starting point is right here, it swings one way, but then it swings back to the other side. So if we were to represent that on a graph, if this is our midline, it starts, it goes one way, then comes back and goes the other way, and so on and so forth. Okay, so this, I know that this goes below 0, but we can move it up, and we can have a starting point be our min or our maximum. So this is an example of, if we're given a minimum, use negative cosine. If we're given a maximum that occurs first, use positive. In this case, we're given both, but our minimum, well, and you need to be given both, our minimum occurs first. Okay, so our minimum was 2.9 years, occurs before 5.1 years. So if we were to draw this from 0, we'd know that we'd start at 200, which is our minimum population. We'd go up to about 800, and then we'd come back down. Okay, because I have a minimum population that happens first, so I'm using opposite of cosine. And it goes up, and then I know that it has to come back down because they said it was sinusoidal. So now what we have to do is extrapolate more information. So for example, we know negative cosine, but what would be helpful would be its midline, its amplitude, horizontal shift, and vertical shift. Actually, the vertical shift is the midline, so it's period. All right, so our period, or our amplitude, we get from 800, so our max minus our minimum divided by 2. So 800 minus 200 divided by 2, Amplitude is 300. Our midline is just basically you find what's right in the middle of 800. So you can take that amplitude and just add it to the minimum, and that'll be your midline. So our midline occurs at 500. So our midline is at 500, which also happens to be our vertical shift. So we know vertical shift is 500. Okay. Horizontal shift. Now here's why I started here, because if our minimum is at 200, I know that that occurs at 2.9 years. So I'm going to shift this over to 2.9 years. So I take this whole thing. So now I'm looking at, basically if I was to continue this down, I'm looking at this. Okay. And I know that its maximum occurs at 5.1 years. So that's it. This is at 5.1, 800 basically. Okay. The other thing we need, so we've got our horizontal shift now. We shifted it right 2.9. Our period we can get from this. So this is at 2.9 on our x-axis. This is at 5.1. So 5.1 minus 2.9 is 2.2. We know that this is half of a period of cosine, so we can take that and multiply it by 2. So now our period is 4.4. So we have all the information we need to graph it. Obviously, you have to continue the graph because we're talking about a real-world situation. Boxes just didn't magically appear after 2.9 years, and they said it was sinusoidal. So you can find this other maximum by saying, okay, 2.9 minus 2.2 is 0.7, so that's going to be the next time it hits 800, which, if you look, that's just about right. All right, so now as far as the equation, we got all the information we needed for the equation. We know that it's got an amplitude of 300, which is that. So that's the amplitude. Okay, we know that we shifted, we've reflected it. So that's a reflected cosine, so negative cosine. We know that that k is pi over 2, because remember, the period equals pi, or 2 pi over k. Okay, we know that the period is 4.4. So if we want to find k, because remember, k is what goes in here. So we end up with k over, you could put 2 pi over 4.4, or if you wanted to reduce that to pi over 2.2 like I did, either way is fine. Okay, we know that we shifted it right 2.9. So remember, minus 2.9 means we shifted it right. And then we know we shifted it up 500 because this number is always where your midline's at. So that would be your function. Predict the population when it's 7. It's just a simple matter of plugging this into the calculator. Now, something that I should clear. When we read this, that's all well and good. But when you plug this into your calculator, you're going to want a parentheses. So 2 here. So basically, you're going to want to plug this in like this. So negative 300 cosine, parentheses, parentheses, pi over 2, close parentheses, another set, t minus 2.9, close them both, and then add 500. Except we know that t is 7, so you replace t with 7, and you should end up with 227. The other thing you can do is if you put it in this same way, if you put it in this way into your graph and you graph it, you can hit, so graph, trace, 7, enter, and then look at your y value. It should be that. All right, so that's 2 ways of doing it. Yes, you'll be able to use your calculator. All right, so they're an endangered species when their population drops below 300. Between what 2 non-negative values of t were foxes first endangered? So that 300 goes in right here. Now what we're going to do is we're going to slowly get these pieces of the equation over to here. So again, remember that this is really this. Okay, so first let's move this 500 over. Which will give you negative 200 equals negative 300 cosine of pi over cosine times pi over 2.2 times t minus 2.9, so that's all quantity. And then we're going to divide both sides by negative 300. Okay, this is going to become positive 2/3 because we can do that. So you'll have, now you need to get rid of this. Now remember, this isn't cosine pi. You're not dividing both sides by cosine of pi divided by 2.2. You need to get the cosine away by itself. So you basically take this. So when you plug it in your calculator, you're going to hit that second cosine. So second plus cosine, and then you're going to hit, you're going to see parentheses going to come up. You're going to put 2 over 3 or 2 divided by 3 either way. Okay, and you're going to end up with, let me see, on mine, because it's going to be something like 0.8444. Let's see. So you end up with 0.8410. Now, this happens at two places, so that means that we need a positive and a negative. So it also at negative 0.8410. Which, so you end up with this. So you have a positive 8410, negative 0.8410 equals pi over 2.2 times t minus 2.9. So you're going to divide both sides by, you're basically going to multiply by 2.2 over pi, or if you want to think of it as divide by this, that's fine. And you're going to do that with each of them. And that's going to give you these two numbers, negative 0.58899 and positive 0.58899. Then we have to add 2.9 to both sides, to each one of the numbers. I have no idea what I'm writing there, so, and that's going to give you these two answers. So at those two values of x, so at 2.3110 years and 3.4890 years is when the is the period of time that the population dropped below 300. So you would write that. You could also write your answer like this, and this is actually probably better. Write it like that, in interval notation. So in that interval, the population was below 300. And then this, finally, what does each aspect of the graph means? Period. That's the time the population rose and fell before repeating. There's one way you could say it's the time the population took to be at its lowest, go to its highest, and come back down to its lowest. Midline is your average population over one period. Amplitude is deviation above or below. That should be max deviation above or below average population. So that's just how it works in this case. All these problems you're going to approach the same way. So hopefully this video helped, especially for those of you that may not have gotten as much time in class. So if you have any questions, you can try and find me before class.